Welcome back to our last podcast episode, where we will delve in the fascinating world of architecture and construction, exploring the innovative methods that shape our built environment. I'm your host Daniela, and I'm joined today by Itzel and Yazmin. We're excited to explore a really interesting topic with you today.
Hey everyone, we're super excited to dive into a really fascinating subject today. We're going to talk about how buildings framed with steel or concrete are cladded with materials like brick, stone, or precast concrete. These materials are more than just decorative, they serve a crucial role in blending strength with aesthetics. They create a balance that is essential to modern architecture, bringing together both functional and visual elements that contribute to a building's overall character and stability.
That's right. While these cladding materials might only be a thin layer on the exterior of the building, they provide a critical sense of solidity and permanence to the structure. But here's a key point. They aren't load-bearing like the walls you might think of in traditional buildings. They don't carry the weight of the structure. Instead, they serve as distinct purpose of providing protection from the elements while enhancing the building appearance. This distinction is fundamental in understanding how these materials are integrated into the construction process.
So materials like brick or stone may appear to be holding up the building. Their role is much more important, let's say. So they aren't actually responsible for supporting the weight of the structure. Instead, they function as a protective and aesthetic layer that shields the inner, more structural components. But here's an interesting question. How do these materials adapt and move with the building's frame over time? Itzel, can you walk us through that?
Sure, I'd love to. When these veneer materials like brick or stone are attached to a building structural frame, they need to have the ability to move with the structure. This might sound a bit strange, but buildings aren't static. They shift and settle over time due to temperature changes, weather conditions, and even the natural settling of the ground beneath them. The challenge here is ensuring that these exterior materials remain securely attached, stay waterproof, and withstand the movement of the building without cracking or becoming loose. Despite being only a few inches thick, they need to stay intact. So detailed construction practices are critical to making sure that the materials move with the buildings while maintaining their structural integrity.
That's right. This is where the Masonry veneer technique comes into place. It is typically made from materials like brick or stone, which are applied to the building's frame, leaving a small cavity between the veneer and the backup wall. This gap or cavity is not just for spacing, it plays a key role in moisture management. It prevents moisture from being trapped inside the layers, which could otherwise lead to mold or structural damage. This space allows for proper drainage and air circulation, keeping the building dry and preventing damage to the materials and structure behind it.
Exactly. So let's break down the construction process step by step. The very first thing that's installed is a component called a shelf angle. This small but crucial piece is attached to the spandrel beam of the concrete frame and serves as the support system for the veneer. It's often an overlooked detail, but it plays a vital role in holding the veneer in place securely. Without it, the entire cladding system wouldn't be stable, and we would risk compromising the entire structure. So, as simple as it sounds, this shelf angle is key to keeping everything in place.
Right. Once the shelf angle is securely in place, the next step is adding thermal insulation. Typically made of foam or mineral wool boards, this insulation layer serves a dual purpose. First, it helps to prevent heat from escaping the building, improving energy efficiency by maintaining consistent indoor temperatures. But secondly, it also helps to prevent any condensation from forming on the inside of the cladding, which could potentially lead to moisture issues over time. After this, continuous flashing is installed. Flashing is a thin material that helps prevent water from entering the structure, ensuring that no water seeps through and potentially causes damage.
Exactly. After the flashing is laid down, the first course of bricks or stones is set. This first layer sits directly on the top of the flashing in the shelf angle, forming the base of the cladding. It is during this phase that something really interesting happens. Weep holes are created. These small gaps left every third head joint are essential because they allow water to drain off of the cavity between the veneer and the backup wall. Without these weep holes, water could accumulate inside the cavity, potentially causing serious damage or mold growth.
Okay, so once the first layer of veneer is in place, the backup wall starts to come together. This backup wall is the core of the entire system, providing essential structural support for the cladding. It's typically constructed with concrete blocks, and the first course of blocks is reinforced with vertical bars. These reinforcing bars are crucial because they tie everything together, ensuring the entire assembly remains solid and secure. They add additional stability, and without them, the wall wouldn't have the strength necessary to support the rest of the building's framework.
Speaking of ties, this step is absolutely crucial in the process. To keep everything securely in place, joint reinforcing and stainless steel masonry ties are used. These ties are installed between the veneer and the backup wall. They ensure that the brick veneer doesn't shift over time. Without these ties, the veneer could start to loosen, which could compromise the integrity of the entire cladding system. These steel ties act like the glue that keeps everything from moving out of place, making sure that the cladding stays attached for the long run.
And we can overlook the importance of expansion joints. As buildings settle or expand due to temperature fluctuations or other external factors, the materials used in construction needs to be able to shift without cracking or breaking apart. This is where expansion joints come into play. These joints are installed at key points along the wall, and vertical expansion joints are with Baker rods and a special sealant. This ensures that no water can seep through these joints and that the materials can expand and contract without causing damage to the structure.
Exactly, so from that point, the wall continues to rise in increments. Typically, the construction proceeds with 16-inch increments, which translates to about six courses of brick or 2 courses of concrete masonry. This method of gradual step-by-step construction allows workers to maintain precise control as the wall grows taller. It helps ensure that each layer is securely attached and that the overall system remains stable and level.
They also use a really clever technique called 8 blocks in the backup wall. This method helps avoid threading blocks over the tops of reinforcing bars, which could otherwise slow down the construction process and make it less efficient. By using 8 blocks, the process becomes smoother and quicker, allowing the workers to get the job done with more precision and less hassle.
And once all these elements, the masonry, veneer, backup wall, and insulation and ties, are in place, the result is a building that is not only structurally sound, but also weatherproof, and durable. The combination of these materials ensures that the building is both strong and aesthetically pleasing, giving it that solid, permanent feel you get from brick or stone exteriors.
And that's the beauty of using materials like brick and stone, right? They provide a sense of permanence, of something enduring and lasting, while the entire system of masonry, veneer, and concrete backup walls works together to ensure the building remains secure, energy efficient, and resilient against elements. It's a smart, integrated approach to modern construction.
It really is the perfect balance. In architecture, we aim to achieve that feeling of something unmovable, something that stands the test of time, but we also have to ensure that the building performs efficiently, is energy efficient, and can stand up to the forces of nature. It's all about getting that balance right.
Exactly, and with careful detailing and precision, we ensure that the building not only looks great, but stays intact for years to come. The combination of the masonry veneer, the concrete backup walls, and the thermal insulation creates a system that is both reliable and durable. It is a smart, efficient way to build that stands to the test of time.
Alright, let's shift gears for a moment and dive into another critical topic, improving the thermal efficiency of brick veneer walls. This is particularly important in the context of larger buildings where the potential for energy loss is a substantial concern that could lead to higher operating costs and reduced comfort levels for occupants. In these structures, ensuring that the building's thermal performance is optimized is key to energy savings and sustainability.
Yeah, so here's the issue that we need to address. In a typical masonry wall system, there are metal components that support the exterior, such as shelf angles. While these components play a crucial structural role, they unfortunately introduce a problem when it comes to thermal efficiency. These metal parts, because of the conductivity, act as thermal bridges. They create a direct path for heat to flow in and out of the building more easily, bypassing the insulation layer. This can significantly reduce the overall thermal efficiency of the wall by as much as even 40 to 50%, which represents a huge loss in energy and consequently increases the building's operational costs.
Exactly. The concept of a thermal bridge is straightforward. It occurs when heat is conducted through a material such as metal much faster than it is through the surrounding materials like insulation. Insulation is indeed intended to slow down heat flow, but the metal components bypass that barrier. This means that significant amounts of heat can either escape from the interior during the colder months or enter the building during warmer months, leading to increased energy consumption for heating and cooling. This is one of the primary reasons why addressing these thermal bridges is so critical to improving the energy performance of the building.
But there's good news. Fortunately, there are solutions to reduce this heat loss. One of the most effective ways to mitigate the impact of thermal bridges is by using thermally improved veneer ties and shelf angle connections. These components are specially engineered to minimize the flow of heat through the metal elements. By incorporating these advanced designs, we can enhance the overall thermal efficiency of the wall systems and reduce heat loss to less than 15%, which is significant improvement in energy performance.
And that's right. Sorry. These thermally improved connections not only help reduce heat transfer, but also allow the insulation to be placed continuously behind the shelf angle, ensuring that there are no gaps or disruptions in the thermal envelope of the wall. This continuity is essential for maintaining a consistent insulation layer, which in turn improves the wall's thermal efficiency. Furthermore, this design approach helps to prevent moisture accumulation, which can be problematic because it can lead to corrosion in metal components and potentially create structural integrity issue over time.
There are several different types of shelf angle designs that can contribute to better thermal performance. For instance, knife plates, which are welded connections, offer a strong structural bond while also minimizing thermal bridging. Another design approach is using overlapping or back-to-back angles, which are bolted together, offering additional strength while reducing the path for heat to travel. One of the most effective solutions, however, is the use of structural thermal bricks, which are materials designed specifically to have low thermal conductivity and high strength. These bricks are placed between the metal components and the building structure to create a barrier that prevents heat from transferring.
Exactly. The key to improving thermal efficiency lies in choosing materials that do not conduct heat well. High-performance composites or materials that have low thermal conductivity, like plastic or certain advanced polymers, can make a huge difference. Even switching to materials like stainless steel, which has about 3 times less thermal conductivity than regular steel, can significantly reduce the thermal bridging effect and improve the energy performance of the wall. Small changes like this can lead to much larger savings in energy costs over the long term.
And it's remarkable how the right material choices, especially when coupled with intelligent design solutions, can have such a big impact on a building's overall energy performance. But it's also important to know that the way the veneer is assembled is crucial, especially when working on larger buildings. These techniques used for applying and attaching the brick veneer to the structure must accommodate the unique requirements of these larger systems to ensure optimal performance.
In larger buildings, the installation of the veneer cannot follow the same method used for smaller buildings. Typically, the veneer is divided into larger rectangular panels that are separated by expansion joints. These joints are vital because they allow the building to settle and move without the risk of cracking or damaging the brick veneer. Expansion joints give the building flexibility, allowing it to respond to things like thermal expansion and shifting, while preventing the veneer from being stressed or cracked during these movements.
That's right. At each floor level, you'll find a horizontal expansion joint right beneath the shelf angle. This joint is designed to absorb the movement from column expansion or beam deflection. It allows the building structural components to move independently without causing stress on the wall or the veneer, ensuring that the brick veneer stays intact and free from damage over time.
In addition to horizontal joints, vertical expansion joints are also essential. These joints allow the veneer to handle any stresses that might occur in the horizontal plane, such as those from thermal expansion, settlement, or even wind pressures. Without these vertical joints, cracks would likely form in the veneer as the building continues to move. So, having proper expansion joints in both directions helps ensure that the brick veneer remains structurally sound throughout the life of the building.
Another critical element in the overall system is the flashing above the shelf angle. Flashing plays an important role in directing any water that might get into the cavity out of the wall, preventing moisture buildup inside the structure. If moisture is allowed to accumulate, it can lead to serious issues like corrosion or metal components or freeze-thaw damage, which can deteriorate the wall over time. The flashing is an essential part of maintaining that durability and longevity of the wall system.
Exactly. Flashing is typically made from corrosion-resistant materials such as copper or stainless steel, which are designed to withstand the elements for many years without deteriorating. For the parts of the wall that are hidden inside the cavity, flexible waterproof membranes such as bituminous or EPDM sheets are often used. These materials are easy to shape and seal around components, offering an additional layer of protection against moisture infiltration.
So the goal is to create a system that allows the wall to basically breathe, meaning it can expel moisture that enters the cavity, while still keeping water out to prevent any damage. This is why brick veneer with a drainage cavity and backup wall is such a great solution. It provides the necessary ventilation and moisture management while maintaining the structural integrity and thermal efficiency of the wall system. Okay, so now let's wrap up today's episode by talking about about stone and brick veneer cladding with metal stud backup walls. This is a common system used in modern construction, and it has some unique advantages and challenges.
That's right. Steel stud backup walls are lighter and quicker to build compared to concrete masonry, but the catch is that steel is more flexible, which can lead to deflections in the wall. This means mortar joints can crack, weakening the veneer over time.
Exactly, and when that happens, moisture can get into cavity, causing even more problems like corrosion of the masonry ties and damage to the sheeting panels.
But there's a solution for this. These systems are engineered conservatively to ensure enough stiffness in the structure to protect the veneer from wind load stresses.
The key is selecting the right sheathing material and masonry ties. These need to resist moisture and corrosion, which helps prevent structural damage over time.
The masonry ties also need to make a direct contact with the metal studs, not just the sheeting or insulation. This is critical, especially when the wall is exposed to high wind or seismic forces.
And whenever these ties go through the air and water resistant barrier, they need to be sealed properly to prevent water from entering the wall.
Another thing to keep in mind is that the system for attaching shelf angles has to be adjustable. This ensures that the veneer stays level and vertical even if the structural frame isn't perfectly plumb.
There are several methods for adjustment, like slotted holes in back-to-back angles, shimming, or leveling bolts. This ensures the veneer remains perfectly aligned.
One last thing to mention is prefabricated brick panel curtain walls. These panels are assembled in a factory, which means they don't require scaffolding and can be installed much more quickly and safely.
Exactly. Masons build the panels in a controlled environment, which is much safer than working at heights. Once the panels are ready, they're fastened to the building with minimal hassle.
The panels are self-rigid, which means they don't need an additional structural support, unlike the metal.
Now let's talk about monolithic stone. Monolithic stone cladding features large stone panels attached directly to a building's frame, giving the structure a smooth, continuous stone exterior.
These heavy panels are supported by steel plates, ensuring weight is transferred safely. Additional bracing provides lateral support, preventing shifts over time.
So basically everything is bolted in place, which welds for an extra security.
And next topic would be insulation and water resistance. Insulation is crucial, using materials like rigid foam or spray foam for energy efficiency, especially in colder climates.
While the stone serves as a water barrier, the ceiling joints are vulnerable. To wear, leading to potential water issues over time.
And regular maintenance of these joints is essential to prevent damage.
This for stone cladding on steel trusses. This system uses prefabricated stone panels mounted on steel trusses, designed to handle weight and wind loads.
Steel trusses connect to brackets, transferring the load to the frame, with ceiling joints still posing a potential water risk.
A non-structural backup wall provides extra protection.
When comparing the two systems, both monolithic cladding and stone cladding on steel trusses offer durability and insulation, but require maintenance, especially for water management.
It is important to consider both aesthetic and long-term performance.
So moreover, precast concrete curtain walls are factory-made, offering strength and aesthetic variety, able to withstand wind, gravity, and seismic forces.
They can include finishes like ceramic tile or stone and attach directly to the frame for easier installation.
Precast panels may be conventionally reinforced or pre-stressed for added strength.
And on the topic of energy efficiency and water drainage, precast concrete sandwich panels provide excellent insulation, keeping buildings energy efficient across seasons.
These panels are designed to redirect water, preventing damage.
Two ceiling joints ensure the building remains dry and energy efficient.
So, GFRC is a lightweight, flexible material that's easy to transport and install.
It offers design versatility with intricate shapes and various finishes.
Reinforced with glass fibers, GFRC ensures durability and can accommodate slight movement, ideal for temperature fluctuations.
And precast concrete curtain walls, especially with innovations like GFRC, offer strength, energy efficiency, and longevity.
With evolving technologies, these materials are also becoming more cost effective.
The construction industry is evolving, making buildings stronger, more sustainable, and visually appealing.
For exterior insulation and finish systems, also known as EIFS, combines insulation and an exterior finish using boards, mesh, and the final coat of cement or acrylic.
It also prevents thermal bridging and improves energy efficiency, particularly in colder climates.
EIFS is customizable, which offers looks like stucco, brick, or stone.
Drainage and moisture management in EIFs has evolved to allow moisture drainage, preventing water damage.
The drainage well system uses a water resistive barrier for improved moisture management.
So EIFS meets strict building codes, especially for wood frame and tall buildings, ensuring fire safety.
It provides energy efficiency while meeting fire safety regulations.
Conclusion for EIFS. EIFS is a versatile solution for new builds or renovations, offering a balance of aesthetics, insulation, and durability.
It is energy efficient, safe, and flexible.
EIFS is a smart choice for modern construction, bringing efficiency and safety to both new and upgraded buildings.
Well guys, to sum up, we've covered various building systems like stone cladding, precast concrete, and EIFS, each offering unique benefits in durability, energy efficiency, and design. As construction technology advances, these solutions are becoming more sustainable and cost-effective. Thanks for listening and see you next time.